This month's madness is the Blinding Light of Destiny from Artix Games. This marks the first time a video game company has reached out to me directly about making one of their things, so congratulations to them for getting ahead of the curve. A couple of things make this axe unusual. The heads are going to be very heavy. I'm going to make them out of 3/8, and it's got lots of these bits on the handle that look like they're turning a lathe, so we're going to be seeing some of Mark in the video.
Mark here.
And then when it's all finished, it gets brass plated, so this is going to be a golden axe. The base plate I have is so big I had to rejigger the vinegar bath. I'm kind of curious will I have enough vinegar to bury these guys. Plates are separated by matchsticks. Horror lurks in here. Gross. Gross. And that, did it work? Oh my god, it worked. That's the, that was a really rusty scissors I found. How long has that been in here? It's been a couple of weeks since I messed with this. But I'll use that to water out the other thing. Okay, hopefully that does it. Keep the bugs out, keep the heat in. The heat will help the plates cook. The hot vinegar takes the scale off faster than the cold vinegar.
Groovy. Hello again, folks. I am doing some work for Mike, and as I'm sure you'll notice, got injured, missing a chunk of finger now. I can make a joke if you really want it, but I'm not gonna go into it. I'm annoyed over how it happened and why it happened. So, without further ado, I'm just gonna show you guys what I'm doing for layout, and then we're going to get to actually machining the thing. This is the first piece of stock that I am turning into the head of this mace. This is 3-inch cold roll solid. It weighs, I don't know, 60, 70 pounds, something like that. I'm giving you my best guess on that. Once I got this more or less indicated in the lathe, and I put little blind hole there to give my tailstock something to bite into and keep the thing from wandering. I got this end dialed in to where it should be, and then I went through and I put markings at where each of the individual stops and starts are. Since this is an interrupted cut on a chunk with a heck of a lot of kinetic energy when it's running, and my little old lathe, I'm gonna do what you saw me doing last time. I'm going to go slow as Christmas, and I'm gonna slowly peck away. Come up to about where it starts, and I took a couple of test passes just to make sure I was following along and doing what I should. So I know that I want to go a hair past 5 thou, and I know the tail back here is slightly off center, so I'm not quite catching all 4 corners of this thing at the same time. And this is an occasion where I'd really like to have a guard of some sort that clamped onto this to, just in case the worst happens, but I also don't want to take the amount of time that it would take to fabric cobble such a thing. So essentially that is what I'll be doing. Since I am trying to be cautious on this, I'm probably not going to be advancing anything more than probably 5 thou per pass. You know, that means I'll be advancing the tool here into the work and taking off 5 thousandths from this corner and from the opposite corner, which means essentially I'm reducing the diameter of corner to corner on this by 10 thousandths per pass. I've got several hundred passes to do to get this down to the diameter I want. All right, so this is end of day one for working on this pig. This section down here, I've got it set to 2.5 inches right now. I started drawing the bevel that goes from square face to round. It's 67 degrees and change, thereabouts. I started cutting that, and then I realized on all the drawings that Mike and I have exchanged, we're looking just at this surface and not at our 3/4 view from the angle here. So I need to touch base with him and see if he wants me to carry this slope up all the way and have a smooth transition going from square to round, or if he wants me to have this swoop in very sharply from the square face so it meets on where the transition at this point goes from square to round, and have that curve right here kind of do most of the work for getting it to do that. Curving it is going to be the bigger pain in the butt, but I can make it work either way. More tomorrow.
That's a relief. I mean, on these, on the thicker plates, you can be more guaranteed that there won't be much distortion. But if there was distortion, I'm not sure how I'd. This Hardox, 3/8 Hardox. Somebody would look at like a giant pneumatic press, maybe, but I don't know. I don't think there's anything hand powered I could do here that would affect it much. It would probably burst that straightener thing I have set up. Oh, don't you love the weather? My template feels all damp. This area stays here. I just wanted the piece of paper. This is actually a bump on top of these 2 pieces. 3 pieces. It's like a sandwich of different plates. It's going to be very heavy. Put this in the middle. We avoid any sort of heat interference, hopefully, with the edge. Not that that matters on this one because it's getting the brass plating, but for my own professionalness, I may have ordered the plate a little bit bigger than I needed to order it, but you know, it's not too bad. I might grind out the front, plasma cut out the back.
Alright guys, end of day 2. This is where we're at. Mike finally got back to me about what's going to be going on with the transition, where this goes from a square piece here and how this needs to go. It turns out this line needs to be the more or less absolute end of the transition. So it has to be starting the curve all along there. Easiest way I know to do this is to just go in and start cutting from the line at the corners here. So pretty much take it down to right at 3 inches to get that initial transition, and then give a very sharp curve for the corners. That way that transition will be extremely obvious and it'll be uniform throughout. After I actually go through and do the curve on it, it should all come together nicely. That's pretty much all I'm at right now. As you can see, I got the back down here. It's actually going to be handle from down below this point. So you've got some weird another much shorter transition bit right here, and it goes from the 3 inch down to I think it was 2 inch, and then you've got another cone shape right here, and then you've got another little doodly-doo down here, and then a fair chunk of this is just actually going to get cut off. I'm also going to have a small button down here for actually where it'll get welded into the handle. That way it's not going to be a big to-do to actually line it up.
This is a blending disc from Rexcut. It's some sort of weird cotton resin thing. I've used them before. The 3/8 Paradox has more of a surface texture than the 1/4 inch. So that's why I'm going to start off with this guy. I turned the table up at an angle. Really seemed to help with my back and stuff, and being able to see that I wasn't hunched over. I might do this more often for other things. This is a medium interleaf flap disc. Medium grit. This was the cotton fiber and so forth. And then I'll go to the fine version of this, from the medium to the fine version of this, and then to satin paper and stuff. Only 3 more sides to go.
Hi guys, today I am stepping back from working on the battle axe piece to knock out something else I've been meaning to for a while, which is carbide insert holders. These 4 pieces here are tungsten carbide, but essentially they're a heck of a lot harder than high-speed steel and your other flavors out there, so they excel at cutting metal. However, seems for some reason most of the holders you can get for these are made for CNC machines, not 1920 something manual lathes. This is one of the ones that you'd see used in some CNC machines, maybe some of the larger manual engine lathes out there, etc. I also have a slightly smaller one here for triangular inserts, and I wanted those so I'd have a reference to go off of when I was going through and designing and building my own carbide insert holders. This one uses these little triangular inserts, and you'll notice there's no hole in the middle of them, unlike these 4. It goes in here, and it seats in there very, very nicely. And then you go through with an Allen wrench and you tighten this little holder doohickey down. What I'm gonna be doing is basically building something similar to this, but rather than going through and having an arm or some such to actually hold it down, I'm just going to be using a machine screw right down through the middle on these. The other thing I'm going to be doing different is, since I have 4 different flavors to work from here, I'm going to be using 2 different sides. I'm either going to have like this corner and this corner having tools on them, or I'm going to be more likely changing the whole profile of the end. It should work. We'll see. Alright guys, after far more time than I thought this project should actually take, I'm finally at the point where I'm ready to actually try using these. I've got slots milled in all 3 of these, so I actually can go in and out on throat. I made myself a little shim here. I've got a new T-nut and a stud in it that I faced off and made all nice and pretty. So I figured I might as well go ahead and videotape either my success or shame. I've got the bolt head that was actually the other end of this, because there's only so much effort I'll put into things. I've got it chucked up here. I just want to try facing it off with each of my 3 tools that I made here to see whether or not I'm at the right height and how it cuts and whether or not anything's going to explode. So let's see what happens on this. And I am open to critique and criticism for how I'm actually approaching using these carbide bits. I'm assuming that, you know, as that's the cutting surface, primarily you're going to want to approach the work with that surface and not have, you know, up here coming onto it. But I don't do much with carbide normally. Also, I made myself a couple of specific nuts so I can use the original wrench that came with the lathe. Bring her in and fire her up and see if it goes terrible or not. So I'd say that first one passes muster, finally. I've got no complaints outside of, dear God, this took me way longer than I thought it should. So I'm gonna flip around and check the other 4 ends that I have to, and then I'm back on the battle axe.
When I make a blade out of 1/4 inch, I give it a 1/2 inch bevel. When I make it out of 3/8, which I don't do very often, give it a 3/4 inch bevel. I'm trying to remember which hole it was. It was the 3/4 inch hole. It was this guy. Come on. This one. Started grinding. Notice it felt funny. This disc is cracked. I think I know when it happened. This grinder took a fall off a table. But if this one broke, I mean, I might be safe, but there was like only a thin cutting disc that did this to me. So, different disc. This one goes in the trash. Halfway.
Kate, A, or Fate entered.
Ilye, eBay, NJ, Unse.
Nit A, Unse. Ore, O, State, Earning Late, Pay, Attenway.
eBay.
They work. I had to adjust the seats here and there a little bit, but it all does what it's supposed to now. And part of the reason I'm happy about that, there are several segments of this axe that are going to be round. And in other words, they're going to have a negative curve to them. And rather than going in with a round file like I have done previously on some of the Buster Sword parts and whatnot, I actually have a cutting tool that is round. I actually just finished curving the shoulder up in here, so I've got not a perfectly smooth transition, but a nice rounded one. And it was much easier to do with this than it would be to try and run the hand wheels to get it kind of round and then go in with a round file. So I'm pleased. So now I've got to finish cleaning up in here, which I don't believe I can actually do with these tools because this is a very tight spot. But on the bright side, now I don't need to. And I'm running much slower and have my back gear on the lathe engaged to further slow down the speed of rotation. Also makes it far more noisy, because at one point one of the teeth on the back gear decided to crap out on me, so I had to very carefully file a new one in place, which I did about as good a job as you'd expect, which is to say mediocre if you're generous. And after I go through and clean up this bit, I'll cut back on, and I'll probably be using one of those carbide tools again to do some of the other rounding and whatnots. Alright, so I've got this curve here, right where I want it, and I've got that shoulder into where it's supposed to be. I've got the maximum travel for my compound set where it needs to be for the next cut, and I've got my compound also set to the appropriate angle. So now I get to cut about a 72-degree angle going from about here all the way back to this edge. And then I get to make that angle. After I get it straight, I'm gonna go back in with this one again and make it curve slightly to get in there. Also, since I'm done with this, and I'm actually using carbide inserts now, and I've got enough material off this that it's mostly balanced, or at least it's balanced enough for me to be comfortable. I turn the speed up too. So there's my Sharpie mark as a reminder. Nope. And that is why all you guys that keep telling me, oh no, you can go faster. No, I can't. Yeah, I'm not going to try and pull a rat's nest out of this while this is running either. I gotta say, these inserts, they definitely are leaving a much higher surface finish than a lot of the other crappy ones I've worked with in the past. My best bet for getting around this without like slicing the shoulder off this, and I don't want to do that. I like there being that much meat on it. I gotta say, I'm fairly pleased with how this all turned out today, too. Should have this chunk finished tomorrow. Good morning. Plan for today, obviously, get this thing done and finished. I'm going to be taking this section here down to about this scribe mark down to 1.25 inches. I've got my stop installed at the appropriate point, so it's going to leave me just a hair beyond this mark so I can go through and actually face it after I've got this diameter down to 1.25 inches. I'm taking it down to that so Mike actually has a piece to sleeve the head here onto when he is attaching the head, which is what this will be, onto the handle. So without further ado, we're going to see whether or not this one behaves as I expect it to. I think I was taking too aggressive a cut. Yeah, it's not liking it going that direction. Let's try it the other way. Yeah, I think I'm gonna pause and get my change gears installed. Or not the change gears, the auto feed. So I'm gonna do that and I'll be back in a bit.
Drilling little pilot holes for the plasma cutter. You can start off from a blank with the plasma cutter, but it makes a big mess. And like I don't want to mess up any of these lines, so little pilot holes for the these inner pieces. Of course, it would have to be the very last cut that something went into my eye. So I got the spark out of my eye, but it left a little crater on my iris. I don't know, it'd be fairly hard to see on this version. On this close-up, like a macro version of what happens with arc eye, there's a little blemish. Little blemish on the cornea. That's the extra bubbly bit above the iris, right? They heal up pretty fast, but I'll feel like I have a piece of sand in my eye for the rest of the day. Whew. Then I'll do the same from the other side. Just a little bit nervous about using these kind of the quarter-inch plug wells. Normally I'd like to drill it a little bit bigger before putting a plug in. But these guys, this was a little test piece. This is similar to a lot of the diameters on the outer frames that get sandwiched to the axe head. So, and this is an offcut of the 3/8, the same stuff the axe head is made out of. And as you can see, there. Aha! And it had to snap the hardocks off. So, and the amount of deformation, too hot. So, you'd have to be using the axe in such a way that you would have deformed the steel to that level before it popped off. So, I don't know, if you got some sort of like specially trained gorilla to use the axe to attack a van. No, not even vans are made out of crappy stuff. That wouldn't do it. If you told the gorilla attack those rocks to the brakes, provided the gorilla didn't have a heart attack. Like the frames would have to be messed up this amount in order for them to hop off. Which, God, would be a savage amount of force. Can you see the white, the paleness, the whiteness? When metal shears, it gets this kind of, like micro texture. But that's what happened. It's like it was a solid pin that sheared off.
Finally managed to get the feed and speed rate about right. Close enough for me to be happy. Obviously, it took me a while. You get the general idea. I'm gonna keep doing that till this is down to 1.25 inches. Good morning, guys. Okay, I think this is day 8 of me fighting with this. I've got the majority of the taper for the point up here started. I've got to finish that up. It's going to be going back to here, thereabouts. You can kind of see my scribe line. And then we've got another curve to do in here. And then that is this whole thing done. And I can move on to the other 2 bits that need to be done. Okay, so I've got this taper turned. Obviously I've left a fair sized nubbin down here to be trimmed so we can actually file the point in place rather than me having to hope and pray that my 4-jaw chuck would be able to hold this lunk of steel in place. I will be going through and putting a different tool in and cutting the curve in this part right here. Then we will be calling this chunk done. This is what I'm going to be sending off to Mike, and he will do with it as he pleases.
So what I want to do here is I want to tack the frame onto the surface just here at the edge in the 3 points because I want to trim I want to trim this inner ridge to get the frame and the axe head lined up. I've done this to the other one already. Good. Now because of the vagaries of my plasma cutting, these guys aren't perfect, but it seems to be working out so far that it's 58 to the edge, 125 to this edge, and then something 96 or 7, 296 or 7, 296. Come on. 296. Haha! Carefully. Without it moving. 1. 2. 3. And then we'll go check it again. Where's the thing done? Sure it didn't move. 120. Oh, that looks a little bit bigger than 125. Did it slide on me? No. 125.5. I think we'll let that go. Can I get these guys? 196.
That's dinner time.
296. Okie doke, I'll be in soon. Perfect. So the reason I didn't do these sections after joining these to the surface permanently is this. How can I move the camera? See this bump? That little bump there is the difference between what the frame was diagrammed to and the underlying axe head. The frames were a little bit bigger, so now I'm going to take these guys off and then clean up this bit. I just need to smooth out this bump, so that's more of a smooth transition. One of my work lights fell over, so I had to stop to it broke and stuff, and I was sick and tired of it being all wibbly and wobbly, so I rebuilt it out of a piece of rebar. I took the old stem out and I put spikes on the feet so it would grip in here. But like, this project is already run over time, so I'm having to stop to do stupid things like rebuild a work lamp. Oh! At least it's working. Oh man, having to stop in the middle of working to rebuild a goddamn work lamp though, it's, This guy is welded to a stem. Makes the next part easier. God damn it, this finger is still not cooperating. That was actually easier than I thought it was going to be. I was worried that such a shallow bevel would be hard to see the line. And it's not that... I think that's obvious enough. I might take this down more. There's something there I don't like the look of.
Terrible news. I didn't turn the camera on earlier. Thought I had filmed y'all a nice explanation of what the hell I was doing, and no, I didn't. This is actually going to be the bottom piece for the thing I'm making. I've got my distances scribed off on it, so I know what I'm doing. It's going to have a point down at this end, and another little swoop-de-swoop right in here. It's going to have another swoop-de-swoop thing here, and then another curved bit in here, and then this bit bevels down to the diameter of the handle. This down here is going to be another alignment pin for Mike to use to indicate off of when he is welding it together. So now I'm just taking this short nubbin down here down to 1.25 inches, I believe. Then I am going to do the rest of the madness between centers. Alright, this end's cut down. It's 1.25 inches. I went ahead and tapered the end with a file. I've got this between centers right now. I've got everything dialed in to continue cutting it. From this shoulder down needs to be 2.5 inches. This is going to be beveled from this shoulder back here down to this. Since I didn't want to flip the piece around again to use this to cut that angle yet, I'm gonna go ahead and just take this section down here to 2.5, and then I'm going to take the next section down below that, because you remember there I said there's a 3/4 inch curve right here, and then it shoulders down and you got another 3/4 inch curve, and then you have the pointed tip. This section down here, I've got it down to 1 5/8 inches. I've got the shoulder down here cut and faced off. So now I have to go in here and cut the curve for this, and then I'm going to cut this curve. Then I'll probably flip it around and cut this curve. Went ahead and ground the back end off this carbide bit, so it's rounded on the back, which means I can get that tighter radius that I want. In case you're wondering why I'm not just using the same bit I did last time, I have no idea where I put it. Anyway. I'm calling that as good as I can get. Get to back this monster up and recenter it, and try not to wing the camera, because now I get to cut the curve on this one. Yeah, I'm happy with that. Now I'm gonna flip it around, because that way, since I've got this nice and cylindrical and symmetrical, I can chuck it in my 3-jaw chuck here. Okay, got my cutting tool here reground. Now it's ground back to about 60, 65 degrees, thereabouts. I'm eyeballing it so you're not getting anything more accurate. And now I get to go through and finish cutting this down to shoulder, which will take a bit. angle here is cut. Now I get to go through and put a curve in it, then flip it around, point. Alright, this piece is done. Finally, I got my last curves. I've got a little nubbin up here on the point yet, but I'll let Mike take that off. So that means I've got just one piece left on this whole thing, and my part in this build is done. Overall, I really do like how this and the other bit have come out so far. Finish on these is pretty damn good too for the amount of effort I'm putting in.
Can you see the little bits of cut up little pieces at the bottom of the hole? I'm going to have to cut up way more than that. That's the idea. Focus. So that's the idea. I don't know, can you see, but the bottom of the hole is made just out of weld. Everything else that goes on top of that is less crucial, just kind of getting rid of the hole, but that initial part where that's where it's fused to the plate. My plan was to go around and tack all of them first before I did any of them fully, but this one here, I was worried about it just because is it too hot to use the sanding block on? Will I melt the sanding block if I go any finish? I was worried about this one with it being so close to the edge, the clamp here on the tip of it, but it seems to have survived okay. I was worried about, I don't know, something silly like it melting out, or the corner of it here lifting, or any other of that kind of stuff, but it seems to have survived. I need to sand that with the actually that was only I think a 50, so I need to roll it with the 80 drum and then sandpaper it, get experimental evidence that it works. Once I'm sure one of these will go a bit funny. The thing I'm dreading is if they go funny, die grinding them out and trying again. I want to not have to do that. One down, 1, 2, 3, 4, 5, 6. One down, whatchamacallit, 56. I have to do 56 of these little wells. These are all the butty ends of the TIG rods that I refuse to throw out because I'm a cheapskate. Now I have a use for them. That's the second side all welded up. Oh, no it's not. I missed one. I have to fill more material in here. God damn it. That's like the before and after. That's the first side cleaned up.
Last part is in and dialed up. So I've got a swoop that is going to be starting back here, and I've got another slightly smaller swoop back in here, and this will be the last piece. So I've got to take this down to 2.5 And once I do that, I'm probably gonna flip it around and start drilling it out. That way I've got a good solid surface that I know is already trued up to indicate off of when I center it, and it should provide a pretty good gripping surface. And since I'm going to be doing further machining on it later to get the actual curves in place, it doesn't bother me in the slightest to really hork down on the jaws here if I need to. I don't think I will, but you never know. It was a boring job, but I've got this drilled out to 1 inch. I hope you appreciate these high quality puns. The piece it's going to be sleeving over is going to be 1 3/4 inches. So as I do not have a drill bit that big, I'm going to be going in with my boring bar here and cutting this all the way out to that 1 3/4 inch diameter. So I've got 3/4 inch worth of material to remove yet. Bored this out to 1 3/4 inches. I had a bit of a brain fart and had forgotten what the outer and inner diameter on the handle that Mike's going to be welding onto this are. So it's bored out, and obviously I've got this curve here cut. So now I get to go through and cut shoulder to shoulder at 72 degrees, which will bring this into about 2 inches. I think, which means there'll be a 1/4 inch wall back there. So probably this will be the most fragile of the 3 chunks I'm dealing with. I say fragile, but there's not really much chance of it having anything terrible happen. Since we left off, all I've done is cut this down with my bandsaw. So now it's just needs to be faced off on this end and cleaned up with sandpaper. After a brief bout with some sandpaper and a little bit of elbow grease, this bit I'm calling done. So now I've got to go through and get the indicator buttons on the other 2 set up.
There's the 2 frames done. What's that hissing noise? Oh, it's this guy. So figure out how to put on this oiler right. 7/8. Not counting this guy. These frames bring it up to 7/8 thick. The bevel for attaching the axe heads. I want it to be, well, obviously I want it to be deep enough that I can reach all the way into the apex here. But I don't want it to be super wide, because this is super thick material to be welding. I mean, it's not thick in and of itself, but when you add up all the plates together, I'm afraid of burning out my TIG welder, the torch on it. So I put a plate on here when I only ground half, and I think I can reach the head in to just get like the apex, melt out the apex, add material, and it'll almost be like a, you know, like when you do a friction weld. Like, it's not like, it doesn't have to be super deep as long as there's 100% join. So the idea with this hole, which was very hard to drill through the hardened plate, and especially like this awkward arrangement, I couldn't lock it properly to drill it, so I had to have it in the stand-up vise like that, is for the brass dipping. The idea is I'll make a little A-frame type thing. When you dip a thing in brass, you need a way to like lower it into the tank, and normally they advise like drilling a hole through, which I didn't want to do because there was no good place to disguise that. So this hole here And then some 1/4 inch thing like this, and a bar going across, and then an A-frame going down, and that way they can hang it off that, provided their system of lowering it in is not too jerky. Bounce! That's like only 5/16. If there's a 5/16 bounce, then it could end badly. But if it's a smooth system they have for lowering it into the tank, that'll be fine. And so yon A-frame here, and then down at the handle where the leather goes, there's a more regular thing, like a 1/4 inch hole going through that they can run a wire through.
Some of you are probably wondering what the hell I'm doing. I'm supposed to be working metal here. What's with the wood block? Well, you will recall that the buttons I'm gonna have to bring down are on this end, right? So I've gotta take these down to 1 inch. But there's not really anything straight back here that I can grab onto. So I'm going to cut a friction fit or a jam chuck in this end. So essentially what I will end up doing is, once I have this drilled out to 1 inch, I'm going to go through and I'm going to cut a taper that matches the spike here. So when I shove it in there and torque it down a little bit with the tailstock, it should be very solidly and rigidly in place, which means I can go through and actually bring this button down to the 1 inch diameter I need. No idea if that's actually going to work or not, but I'm hopeful. Jam chuck here appears to be working very nicely. Seems like that should hold neatly for getting this cut down, and should provide enough friction for me to go ahead and cut it. Alright, 1 inch. I'm going to take some sandpaper to this as well to get it cleaned up, and probably bevel this end down here with a file a bit to get it nice and pretty as well. And we can call this one just about done. After a great deal more time than I thought this would reasonably take, it's done. I've got a little bit of grease on these to keep them from rusting out. Now I just gotta park them in a box and ship them off.
So these are the parts that Mark sent me for the axe. They're very heavy. Not that that's not to be expected. Seeing him make them and such, there's only one weight they could have been. But it must be like the experience everybody who orders one of my things gets. It's like they see the thing, they see pictures, but then they're always somewhat surprised when they get the actual thing. Holy moly. Let's see. Yes, he told me about this, so I got this guy out earlier. Now, is that enough to start sliding things out? Cap number 1, not cap, collar. Yay! Oh, look at that, that's cool. Collar number 1. You guys are probably sick of looking at this because of all the video edited together, but this is the first time I'm seeing this. That's really great. That's the central chunk. Holy moly. It's good that he left that little nub on. It looks like it did try to eat its way out through the box. Not 2 other. 1 other. There we go. Oh, look at that. I love this thing. Look at it. Oh, that's so cool looking. I shudder to think, like using my method, how long it would have taken me to do all this kind of stuff. I'm just looking, I'm already like working out how I do it, and it's like, no. I don't actually mind if this nib here is kind of not sharp, or if it's a little bit rounded, because this is the pommel. You know, its weight will be left on this guy, so it actually might be better to have it more rounded. It's going to eat whatever floor it's left on. They're going to have like a block of wood that they keep it on. Like if they lean it up using this guy as the thing it's balanced on, it will destroy any floor. Or if it was stone, it'll destroy the nib. So for the handle of yon giant axe, Blinding Light of Destiny, I'm going to use, I think it's 3/8. I ordered this ages ago. It's 3/8 wall, heavy wall pipe, which is, and it's 1.75 3/8 wall. It's bonkers heavy, as like pipes go. But you know, like sometimes when you say that you're using a pipe to make a thing, people do get suspicious. They're like, oh, won't it, if it has a pipe handle, won't it collapse? And I'm like, given human level strength, the probability of this guy collapsing, if compared to if I made it out of a solid, I can't imagine there's any realistic difference between the two, you know? You know, like that's the type of thing you'd only have to worry about if it had like tanks driving over it daily or something. Gently. Whoop. Whoa, no. Come on. Maybe if I curl it up the way. Now to peel this guy back. Ah, man. These parts here, the pointy bits, could be troublesome, but they're not. Cool. And boom. Whew. There we go. Plasticined wall, electrode, then positive on the piece, the black one on the negative on the receiver. Gross salty water. That's only black. This is black because it's stuff I've used before. Strange enough, I find the stuff that I've used before tends to work better. Wait for a second to see is it leaking out in any place that it shouldn't. And then when you are pretty confident that it is not doing that, you turn the power on. My thing's not working. Uh-oh. Thing's acting all crazy. Something's happening in there because it's bubbling. Focus. But I honestly am sure what. So I'm going to leave it in for a half hour and check it. I have a spare one of these vinyl prints provided by Adam of Pretty Hate Machining. So I can try again if it's disastrous. which it probably will be. So this is 3 rounds of the half-hour 3.5 amps, but no volts, mystery volts. So we're going to see how it turned out. I can catch with my fingernail the edge of the etch. So that means that there must be something going on, you know. People were asking me before on a different sword why I didn't I did black oxide inside of an etch, and why I didn't do the the gun blue while the vinyl print was still on, instead of doing it the way I did with a Q-tip and then sanding back. And it's because the salt, the dirty salty water in the remains of the etch, would totally mess up the gun blue. And honestly, they'd mess up just the bare metal too if they weren't removed properly. That salt will make the thing rust like crazy if you don't get all of it. There we go. So yeah, it's there. As usual, I wish it was deeper. I wish my DC power supply thing wasn't acting funny. I've never actually asked those guys was the symbol on both sides, but I'm assuming it is. I mean, it would make no sense otherwise, right? I mean, I guess it could be a story reason why it was only on one side, but it's too late to change now. So what I'm trying to work out here is to position this leather. This is the piece of leather for the handle. Marie made it of my other videos. It kind of looks like a plaited piece of leather. It's very popular on art to do that like plaited looking leather thing, and then never really work out how it works. Like a lot of, especially on the big ones, it's like, oh, it's a plait running up the handle. You just need to find a piece of leather 7 feet long to make it work or whatever. But this one, so this was the closest, strongest. I thought it would be stronger, and because this axe is going to be so heavy that there's going to be so much torque that if this was a delicate plaited thing, I think you would just instantly come undone. So we did it as a flat piece with a pattern scored into it, and I'm going to just bolt it on with the little brass flatheads to match the brass of the actual axe itself. So I've countersunk these so that through the leather they can sink in, get a real bite going on, that it's not just flat on the surface. These guys are the, oh, what's the name for it? You know, the flat ones with the tapered heads. So the idea is I want to sink them into the leather so that there's no, that you can't feel them, that you won't, as your hand twists around, it won't rub off them because they're sunk in. Ah! So there's the one where the tap snapped, because I wasn't standing in the ideal position because I was trying to get footage of me tapping the holes. So I have to re-drill and re-tap this one. I did not try to film me tapping this one for fear that the stupid thing would happen again. And I drilled this one out the tiniest fraction bigger, but it still managed to bite it because the weld is actually, I think, tougher than the base metal. Yeah, it's still grabbing it. There's still teeth in there. This is the bevel. This is arguably the most important weld on the entire thing. This is where you got that big huge piece Markmed for the head locks into the handle. My experiments with handles and stuff is that it's very hard to actually break a handle off on purpose. I remember when we were doing the TV show, they wanted to film a bit where I made like this big junk axe and the handle broke off it. And that was actually dangerous to film because we had to cut like 96% of the material away in order, because I just cut the welds first and it didn't break. And then I cut into the actual pipe itself and it didn't break. And I kept going and going and going till finally the axe head was physically wobbly on the stem, and in the scene I had to lift it up over my head and bring it down. And I was afraid that the axe head was going to fall off onto me as I lifted it overhead before I even got the chance to film the part where it breaks off. But luckily, anyway, it's very hard to, depending on the position of a handle, it's very hard to actually break them off. Like this would, especially since Mark put that peg on the end of the long piece that goes down into the pipe too. I think you could probably safely lift it up and swing it round with just two big tacks either side. But I'm going to do the full bevel grind, etc., etc. Aha! That was too much, probably. I would put a shirt on because I have to do welding now. Now I'll rotate it and repeat the process with the level, just to be sure. So, I tried to film a little bit of me welding it, but it didn't come out right. That's the thing about the filming the welding is, the best vantage point is where I want to stand. So the angle I tried to film it from didn't come up right. Seems odd that the deciding factor of a measurement, this is the side, the deciding factor of, actually no, it was this one. Yeah, because the pipe was going the other way before. That the deciding factor, the deciding measurement on a piece of steel would be the leather instead of vice versa. But the leather was cut first, so that's how we're doing this. If the metal parts had been made first, we do it that way. This was made according to the template, but I'm sure there was, it's leather, it's bound to have moved or undulated just a little bit, God damn it. There we go. $27.67. $27.3. That's millimeters, so like half a millimeter on ground surfaces. The eyeball check works out. I think that's good to go. Equidistant, 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 equidistant. X. X. Equidistant, equidistant. One thing I can't sort out is whether this guy there's little lines, there's lines that come into it, but there's no good way to measure are the axe heads coming in the same distance from the... I guess you could go from the bottom of this guy. Why don't we do that? You can't measure from where they're coming in themselves based on the block, because the block is... Oh my god, even this measurement is difficult. What if I put it this way? Oh my god. I can do it with a random little stick, but that seems... This is just, we're down to pen marks. See, according to the pen mark, it's fine too. But that's a pen mark. I think we're good to weld. This side at least. Filming?
I'm filming, yes.
Oh man, it's very heavy. Hang on. Man plus thing, 299. Oh. Man by himself. 209 is 90-pound axe. Holy moly, why are the axes only so heavy? That's the last weld cleaned up. Now, That's all the structural stuff done. The next thing is the brass dip. You know, once it gets the brass dip, you won't be able to hit anything with it because you'll damage the brass coating. I should really hit it with something now before I get in the car. I'm literally down to the last few moments before I have to leave on a boat. I'll see what I can find. Oh, Jesus. Okay. How am I going to do this? Whoa! It's very heavy. Oh, Jesus Christ. Woo! Just if there's any like crazy scrape once we get it in.
It's recording.
But like
Enough drainage, Robbie?
Something. What's that?
Enough drainage?
Well, he's got holes drilled.
holes there for the hand cover, but like I hope that's enough. You know, see at the bottom. So and then
Is it hollow?
yeah.
Up through there.
Yeah, this pipe, the round part is hollow, and these are. It's probably it does. It's probably. I can imagine it being like fussy draining or whatever, but.
Well, that's just the chemicals that are in there. If there's not holes that are proper, they have to maneuver it around to get it to drain.
And I'm fine with sticking around to help with. I mean, I don't know what your insurance is like, but I'm fine with staying around to help do that because I don't think any human should have to suffer through this.
Don't know that we could have you go down in the playroom and help with.
Brass rod or something.
So now that's that finish.
Okay. Is it a clock? No, I mean that's.
No, it's just a piece of sculpture. It's a replica of a thing that's in a video game.
Why is it not in focus? There, it's in focus. I'm here at Whitman Plating Company, and we're going to get the axe brass plated. Does anyone want to explain the process? Do you want to explain what you guys are going to do?
You have to put it into a strip tank to take off your black welding marks because the brass won't adhere to that properly and they would stick out. After that, you kind of wipe it down and then it would go into your brass tank to be plated. Probably close to an hour's worth of brass.
An hour's worth of brass.
And when it comes out, you'd have to drain it properly, get it all washed off to try to. Different spots like this will leak out and leave a mark. And then depending on what you want your look to be after, you'd hit it with a Scotch-Brite or something to bring your look out.
And this is what I was asking you before. The Scotch-Brite, the brass will be heavy enough that you can rub it with a Scotch-Brite and it won't.
It shouldn't, as long as you don't hit it too hard.
Okay. Yeah, a very fine Scotch-Brite.
Yeah.
Okay, cool. Sorry, I'm in the way. Just sorry. So you were telling me these brass lumps, what's the chemical that it can travel through when there's a current?
Well, your current is on this bar here, runs across and goes to that big rectifier over there.
Yeah.
That brings a charge into the tank, which activates the tank, which brings the brass out of these bags, which will adhere to your piece.
And what's the chemical? Or is
There's the brass itself, there's ammonia, cyanide. Yeah.
yeah.
But these are brass nuggets, so if you clean this off, it'll be totally brass nuggets.
Yeah.
Brass is expensive too.
Yeah.
Brass is very expensive now. Very.
And these tanks are heated up. This one here is 115 degrees. It has a heating coil inside there, which keeps the tank heated up.
You can probably guess this by looking at the footage, but it's you can smell that this is a place where interesting stuff happens.
What you're probably smelling is the ammonia.
Yeah. Thank you, gentlemen. Focus. Focus. Haha. So here we are a day later at the Whitman company. And as you can see, they have left it here, secure in the knowledge that no one could possibly run in the door and steal it. Although they do have it on a thing on wheels. Although it'd be probably to get it out that tiny door. So this part, that gets covered with the leather, is actually perfect for experimenting with. How much, I've already started sanding a bit before how much force. These are our samples, these are the bits that are back to, whatchamacallit. These parts didn't get covered for whatever reason. You can see these are more silver. It would be relatively safe to buff it with a Scotch-Brite. Now they've lacquered it too. I took the lacquer off this part. But let's see now. My guess is 100 grit will just take it off. No! Watch! Hang on. See, it's so shiny now, I can't tell. Yeah, it is starting to come off, but that's pretty good. I mean, it's better than paint. I see, now you can see the starting to take off. Now that mightn't seem like much, but that was more resistant than any of the paints I've tried. And then to get rid of it completely, if you were looking to do that, better than Cerakote, better than Duracoat, better than the black oxide. They'd be all well gone by this stage. Yeah, there's only tiny trace bits of it left. But there we go. So the thing I like to do is I've covered the handle in the Gorilla Tape. I find that it's better to have some sort of barrier. Like, I'm not sure how waterproof the leather is, you know, just if there was sweat. Not that it would matter too much on this one, but just, I think when I gave Marie a section of this pipe to make it with, it was already covered in tape, so to match the diameters perfectly, because it's amazing how a little thing can, you know, change the gap. So, this guy, covered in tape. Started the video callback. Hang on. This is double-sided duct tape, which I'm going to use just along the edge. Haven't used this before, so I don't know how well it's going to work. But the idea, see, I'm trying not to touch it like that. The idea is, whoop. The idea is just to hold down the edge where it tends to bulge a little bit. I totally missed filming me wrapping this guy around, but that's the idea. The you can see from the side, these guys, without the double-sided duct tape, they were more bulgy when I put it on dry. Because of these guys were being squished in, obviously the force was making this thing pop out a bit, but I think it's fine. And so that's what it looks like. Relatively neat, relatively tidy. And then this guy on the side, that's what the seam looks like. I don't know, it might have been better to go with black little bolts, and I could still swap them out easy enough. But I thought, you know, brass would match the brass on this guy. But I'd have to, there's no such thing as black ones. I'd have to manufacture black ones by either painting these guys or getting steel ones and doing the black oxide thing. But I'd hesitate doing the black oxide thing on something that was so close to where people were sweating on it. That would kind of defeat the purpose. Paint might actually be better for these little guys. Unless you can get like special ones that have been heat treated or whatever and have ceramic black tops or something. So now the very last thing is I want to fit a piece of brass into this hole. I luckily have a random piece of brass rod, so now I'm just going to manipulate it, create a little stud that can go in there. It would be disastrous if this was loose, but this guy is too big. The inside of yon hole should be 6, but it's probably more because of the way I drilled it. It's less than 6, and then this guy is 7.7, so quite a lot of material to take down to make it tight. 6.16, and then this guy is 7.75, so quite a lot of I can make it tight so that I can just tap in and it'll stay there. Now, a little bit of Scotch-Brite. There we go. Where is it? There it is, right by the front door. Useless. So there it is. Yon axe finished. Whew, this one was a lot of work. More work than I expected, even with getting Mark to do all the bits for me. Even with getting someone else to brass coat it. Even with getting Marie to do the leather. This one just seemed to go on and on forever. But it's finally done. Whew! I didn't even need the step ladder, I could have stepped up on this thing. Oh well. There we go.